In this video, we'll go through the steps for the repeated measures t-test hypothesis test. So these steps should look familiar. They're similar to the hypothesis testing that we've done with previous chapters. First, we're going to state the null hypothesis and the alternative hypothesis. Then we'll select our alpha level, locate the critical region using the t-distribution table and our degrees of freedom. We'll calculate the t-test statistic, and then we'll make a decision regarding the null hypothesis. So the first step we need to do is to state the null hypothesis and the alternative hypothesis. So in this example, a group of 19 couples were given minimal premarital counseling. The communication quality was studied in men 3 months before and 3 months after the couples got married. In the population, it's normally distributed. A researcher predicted that there would be a difference in communication before and after getting married. This was tested with a significance level of 0.05. So remember, we're talking about difference scores. So we're going to be talking about our hypothesis of our mu, our population difference score. Again, this symbol refers to the mean for the entire population of difference scores. And we wanted to say that there is no difference. The alternative hypothesis states that this mean for the entire population of different scores is not going to equal to 0, that there is going to be a difference. So now, is this a one- or two-tailed test? The description just said that we expect there to be a difference before and after. So it's a two-tailed, there's no direction implied. And we're going to set the alpha at 0.05. So now we need to locate the critical region using the t-distribution table and degrees of freedom. So remember that the example we gave said a group of 19 couples. So we're going to have 19 scores. To get our degrees of freedom, it's n minus 1. So we do 19 minus 1, that gives us degrees of freedom of 18. For 0.05 and two tails combined, we get critical T of 2.101. So this is going to show you this is our critical boundary, and these are our critical regions. If our calculated T falls in these critical regions, we'll reject the null. If it falls here internally, we will fail to reject the null. Next, we have to calculate the T statistic. So in order to do that, we need scores. So here are scores. Husband A, B, C, D, E, F. I didn't have room to put all, so I went to S. Scores before and after they got married. Communication scores before and after, so on and so forth. I don't have all the numbers, so I'm just going to have to tell you that this is the sum of those two. We then calculate the difference. So I've then taken 115 and subtracted 126, 125, subtracted 133. So 115 minus 126 is negative 11. 125 minus 133, negative 8, and so on and so forth. Again, I didn't have room to put everything for display, so we get down here, and I give you the sum total. So just to believe me that everything that falls into in between F and S, we get a negative 229. I then have to square those values. So this is like my x score, right? This is my x squared. So again, remember these formulas are very similar to the one sample t-test, but we're using different scores instead. So I square 11, and I get a positive 121. I square negative 8, I get a positive 64, and so on and so forth. And then this is my sum of my difference squared. And this is my sum of my different scores. So here I have that all laid out here. And just to get the mean difference, we take that sum of the difference score and we divide it by our n. So again, just keep in mind that this sum of the difference scores is very similar to the sum of x, and the sum of the difference scores squared is very similar to the sum of x squared. So for sum of square deviations, we need the sum of our distance squared, so 5,523, minus the sum of our difference score, which is 229, so it's negative 229 squared over our n, which was 19. That's going to give us 5,523 minus 52,441. That was 229 squared, came to 52,441 over 19. That's going to give me 5,523 minus 52,441 divided by 19 is 2,760.053, which is going to give me 2,762.947. Next, I need to calculate the t-statistic. So my sum of squared deviations was 2,762.947. I need to get my, so I've done this, I need to get my variance. So, degrees of freedom is my n minus 1, is my 19 minus 1 is 18. So variance is going to be my sum of squared deviations, 2,762.947 over 18, which is going to give me 153.4971. I'll then use that to calculate my estimated standard error for the mean difference. It's going to be the square root of 153.4971. That's from down here, divided by my n, which was 19. That's going to give me the square root of 8.078. It's going to give me the square root of, or it's going to give me the value of 2.842. All right, now I'm going to plug this all into my t-statistic formula up here. So I've done this. Now, last objective is my t-statistic. So I take my mean difference, we calculate it using some of my different scores divided by my n. So I have a negative 12.05. We assume that the population mean difference is 0. And we're going to put that over our estimated standard error of the mean difference, which is 2.842. And my t-statistic is going to be a negative 4.239. Now we need to make a decision. So my critical t was negative 2.101 and positive 2.01. That's my critical t. My calculated t came out to negative 4.239. This is less than 2.01. It's going to fall way out here somewhere. So my decision is to reject the null hypothesis. So in the literature, we report our means and standard deviations in a statement or a table. It's a very concise version of the test results. We report our t-values with our degrees of freedom. We've seen this before. We report the significance level, or that p-value that we were using. And if we've done that calculations, we're going to report effect size. And effect size is something very important that people are looking at more and more and requiring in published literature. So for that study, we're doing a t statistic analysis. This is my degrees of freedom. This is my calculated t. And this is my alpha level. Now I put here significance because if you're looking at an SPSS output, it's going to list it as significance. And this would be the t value from that SPSS output, and then that would be the degrees of freedom for repeated measures analysis of variance. So it's important to note that observations within treatments must be independent. The population distribution of different scores needs to be normally distributed. It's really not a concern typically unless we have a small sample size. With a sample of over 30, this assumption is typically ignored. And just keep in mind, the larger the sample size, smaller standard error is going to influence our t statistic.